that, we ought to be able to solve by the methods we've been using for the previous problems, right? Like, we could take log base 5 of both sides, maybe. We could take the natural log of both sides. What you guys want to do?
Log base 5.
Log base 5? All right. We'll do it. So log base 5 of 5 to the 3x equals log base 5 of 200 over 6. So that tells me that 3x is equal to log base 5 of 200 over 6, which tells me x is equal to 1/3 log base 5 of 200 over 6. And there you go. Ah. So this right here is 5 to the 3x, right? Plus 5 times 5 to the 3x. So how many 5 to the 3x's do you have here? You got 6 of them. 1 plus 5 is 6. I factored out 5 to the 3x. I've got a 1 plus 5. I'll tell you, this problem's nasty. Like if this was like in an electronic homework system, and I was looking at like difficulty bars, the ones that we've been looking at so far, I'd have like 1 or 2 bars. This one would have like 4 bars, for sure. 4 bars out of 5. It's not a 5-bar problem. Find a 5-bar problem. Just counting ballots. I don't know. Let's see here. 10 over 1 plus e to the minus x. Oh, I forgot I had this problem to solve. So again, so the name of the game is to isolate the exponential, right, if you can. And how would I do that here? I get 10 is equal to 2 times 1 plus e to the minus x, right? And then we could divide by 2, right? And we get 5 equals to 1 plus e to the minus x. So we get 4 is e to the minus x. Which log? We got choices. Log base 10, log base e, log... So this one, we should take the natural log because So natural log of 4 is natural log of e to the minus x. What's the natural log of e to the minus x? Yes, minus x again. So x equals minus the natural log of 4. So I like number 38. Number 38 is a good problem. It's right in the middle in terms of difficulty. Now, yeah, I'm not quite done with the material. Like we'll have to have another class meeting at least with examples more on this. I have one more example for today. So the problems like this are a little bit sneakier. So here we have e to the 2x minus e to the x minus 6 equals to 0. And so this kind of problem, so just to give you a summary of where we are, I've only really shown you how to solve about like a half of the equation types in this section. We've got at least another lecture to cover the other method. Well, no, I mean 4.5, section 4.5, I've only done like representative examples from about the first 44 problems. I'm about to cover number 40, which hits that type. But there's still like 1, 2, 3, 4, 5, 6, about 7 other kinds of problems. It'll take me at least another lecture to do that. So that should be Thursday next week, like after final exam part 1. All right. After final exam part 1. Final exam part 1 is just on test 1, 2, 3. So next class, we'll come back. I'm not going to talk about this stuff at all. It'll be completely a review of tests 1, 2, and 3. Whatever questions you guys got about it. What's that? Thursday. Thursday, yes. I mean, I could move final exam part 1 up to Thursday. I'm just kidding. I don't have time to write it. Sorry. It is Tuesday. I was just messing with. So here, like you try whatever you want, but you will not be able to isolate the exponential. This one, you have to be sneakier. What you do is you let y equal e to the x. Then y squared is e to the x squared, which is, by laws of exponents, e to the 2x. So this equation becomes y squared minus y minus 6 equals to 0, which we can factor as to y minus 3 times y plus 2 equal to 0. And then this gives us either y equals to 3 or y equals to minus 2. In other words, we have e to the x equals to 3 or e to the x equals to minus 2. Then to solve those, we take the natural log. So x equals log 3, x equals log of minus 2. And so putting a box around this and saying that your answer is your way of telling me I don't care on the next test, this is not allowed, right? That's an extraneous solution. We cannot take the natural log of minus 2. Right? So the thing is, this is a sort of a quadratic equation of some sort, which has just one solution because it's a quadratic in e to the x. It's not an ordinary quadratic. But there you go. The only solution here is log 3. So thank you very much. Have a good weekend. Wait a minute. What's today? Oh, man. Yeah. I'll come back for the review. Yeah.